Is the universe fractal? Do all structures repeat themselves on a very large and very small scale? Could this point to the underlying structure of our reality and perhaps prove that we live in a multiverse? All of which we will clarify in this video. So buckle up and stay tuned to the end if you want to have a cosmic identity crisis. And if you like the video, I'm galactically happy for a thumbs up and a fractal comment, because that's how we get the YouTube algorithm to show this video to even more people. Thanks a lot guys and welcome. It's strange, if you look at the microcosm, the very smallest structures, and the macrocosm, the very largest, you often find that many structures are very similar. Here is an example. On the left you see a microscopic image of cells of the human brain and synapse connections. On the right we see a simulation of the structure of the cosmos, the so-called filaments. Amazing similarity, isn't it? So is the universe perhaps just one big brain, or is each brain its own cosmos? Phew, let's take it down a notch and first clarify what the term fractal actually means. A fractal is when you zoom in far enough that you then come across structure that repeats the original pattern you saw on larger scales. When similar patterns appear repeatedly at smaller and smaller scales, then we can analyze them mathematically and determine if they share the same statistical characteristics as the larger structures. And only if that is the case, then it is a fractal. You want an example? Okay, cauliflower.
I hate cauliflower.
But you will love this cauliflower. It is a special variety called Romanesco, and its inflorescence is an absolute, mathematical masterpiece of nature, because it is fractal. So it repeats the same pattern over and over again. That sounds a bit silly in relation to cauliflower, but I find it absolutely fascinating that nature has produced such mathematical perfection. But the Romanesco is not an infinite fractal, not a key to the cauliflower multiverse. Because such fractal manifestations in nature always have only a limited number of self-similar structures. After mostly 2 to 3 fractal repetitions, the cauliflower is finished. So good news for all cauliflower haters, this controversial vegetable is not the gateway to infinity. Now we've talked so much about cauliflower, I need a chocolate chip biscuit first. The principle of the fractal was first recognized by the mathematician Benoit Mandelbrot. Perhaps you have also heard of the Mandelbrot set, where you can generate a fractal with a mathematical formula. We are zooming into the Mandelbrot set, and although we are only seeing the graphical result of a mathematical formula, you could almost think we are flying through our own universe. Mandelbrot was quite obsessed with fractals and even thought that stock market prices could be analyzed and predicted with them, and last but not least he thought it possible that our entire universe is a fractal. That was in 1974, and at that time astronomers had just begun to compile extensive catalogues of galaxies from the depths of space, and the first ideas about the large-scale structure of the cosmos were beginning to take shape. That the universe probably came into being and expanded with the Big Bang was already known, but such a precise idea as we have today thanks to the Hubble and James Webb Space Telescopes was not yet available. Nowadays we have a pretty good picture of what the very large structures of the universe look like. Here you can just see the cosmic web, the largest structure we know. It consists of filaments and voids. The filaments are the bright threads, and in them is all the matter that exists. Almost all galaxies, such as our Milky Way, are also arranged in these cosmic filaments. But in between there are inconceivably huge cavities, the voids. Here there is a yawning emptiness of inconceivable distances of hundreds of millions of light years. They are not completely empty, individual galaxies are hidden in them, but far fewer than in the filaments. Is this cosmic web a fractal? Do we get the same spiderweb-like structure over and over again when we zoom in and out? Yes and no. A close analysis of the voids, for example, amazingly shows that the structure is indeed the same. The few lonely galaxies floating around in the voids form a mini-cosmic web. The filament structure has repeated itself at least once on one level, so in a way it is similar to itself. But one level is not very much, is it? Even our cauliflower was fractal. And in the smaller planes, we can then completely eliminate the fractal structures of the universe from the equation. Our solar system alone looks completely different from another star system. Our Milky Way looks different from other galaxies. Different galaxy clusters, despite many similarities in structure, have a completely different appearance. So if anything, the universe can only be fractal on the very largest structures, and even there it looks lousy. With a lot of imagination, the cosmic network structure can be found again within voids, but by no means continuously. Now some of you will say,
But the brain cell, what was wrong with that?
it is true that structures on a very small and very large scale are partly similar. But that alone does not make a fractal, because for that we would need self-similarity on several, continuous levels. And not just on a very large level and then again on a randomly different level under the microscope. The reason why such very different structures resemble each other is not entirely clear, and although it is a little unsatisfactory, it could simply be coincidence. And ultimately, both the microcosm and the macrocosm are governed by the same natural laws, and some arrangements probably just make sense according to these natural laws. Last but not least, a good portion of apophenia comes into play. Apophenia is the tendency of us humans to perceive meaningful connections between unrelated things. Our brains just work that way. We look for connections where there are none. For example, between the cosmos and a cauliflower, or between this close-up of a raven's eye and a black hole. Definitely no connection there, but we still desperately want to see it. But I also see that now some of you are sorely disappointed and saying,
But I really wanted the universe to be fractal.
there may still be one last way out, one last possibility that takes us to the limits of physics, the multiverse. We just looked to see if we could find a fractal pattern if we zoomed in from the cosmic web, the largest known structure, into smaller structures. And were bitterly disappointed. But what would we see if we zoomed out from the cosmic web? What comes above it? Some researchers assume that our universe is not the only one. Above or beside our universe could be another, perhaps even a mother universe, then a grandma universe, followed by a great-grandma universe, then a great-great-grandma universe, and then even a great-great-great.
One eternity later.
So it is conceivable that above the cosmic web, an even more massive structure could appear, similar to itself. A universe fractal. Because if there are always new universes, then we would really be living in a kind of cosmic Mandelbrot set. It goes on and on with repeating patterns. Each universe a level of a fractal that cannot be comprehended, that cannot be grasped. Absolutely conceivable from my point of view, but absolutely not proven yet, just an exciting hypothesis. Drop me a line in the comments about what's outside our universe. Could our universe be part of a multiverse fractal, or is that complete nonsense? I'd be very interested to hear what you think, and maybe we can get an exciting discussion going in the comments. I'll answer as much as I can, I promise. Be sure to check out the next video too, it's really exciting. And if you want to support the channel, I look forward to seeing you in the space shop. You can find the t-shirts from the videos and plush planets there. Otherwise, I'd say see you in the next video. Take care, guys.